Welcome to Cornell Marine Program's Digital Learning Podcast. This month, we're doing a mini-series on a review of 2021, focusing on marine program projects. And yesterday, we discussed the scallop. Today, we're going to see how Mr. C did with the clue I gave him for the topic of today's show. Hey, Mr. C, how was your weekend?
Yeah, it was good, Rory. On weekends, there's always these projects you got to work on the old list. So I got some done, added some new ones to the list. Weekends, they just go by so fast.
Yeah, Mr. C, I know. Weekends seem to roll in so quick. My project list keeps growing as well. I did get to finish a woodworking project in one of my rooms. So I've been working on this one wall and finally got the painting done.
Yeah, good for you. Speaking of walls, I think you told me the topic for today had something to do with walls. I have no idea what the clue you gave me.
All right. So, Mr. C, do you know about PRBs?
PRBs. The only thing I think I can come up with is I was thinking of your green drink. So how about PRB? Personalized Rory beverage.
That's it. I do like my green special drink, but I'm just messing with you. This has to do with water quality and how we don't want our water looking like my green smoothie, man.
Okay, that's a better clue. I think I know what you mean now. How about permeable reactive barriers?
Yes.
Great. Improving water quality, is really important, Rory, especially nitrogen. And this PRBs, if they can help prevent harmful algae blooms, that's wonderful.
Yeah, now I really didn't know much about this project until I started working on the video. So here's what I found out.
We have a groundwater treatment system installed at this site. It's called a Permeable Reactive Barrier, or PRB. And it's a subsurface treatment, so there's no above ground structures after it's installed. And it's completely passive, so it requires no external energy input, and it relies on microbes that exist naturally in the soil and in the water. And this treatment is converting nitrate in the water, in the groundwater, to nitrogen gas. So that's happening naturally via microbial respiration and metabolism, and nitrogen gas is completely harmless. It makes up 80% of our atmosphere. So with this treatment, we're converting nitrate, which is a nutrient and in excess is a pollutant. We're converting that all the way to nitrogen gas and completely removing it from the water.
Well, as we're all too aware these days, that our surface waters, are impacted specifically by nitrogen. And excessive nitrogen is coming in from on land, from a variety of sources, and all of that goes into the groundwater, and all of that discharges right offshore here and brings all whatever happened in there winds up out there. And so that excessive nitrogen is what's causing these algal blooms, excessive algal blooms. It's also causing changes in even pH and other things that are important to the biota out there. Dissolved oxygen gets impacted. All that algae dies and sucks the air out. So nobody really is aware all the time of groundwater discharge. It's probably the leading input of nitrogen getting into these bays.
So we've been studying this system for a while now. First studying it as a small treatment cell, and that treatment cell worked really well. We published some results on that in Ecological Engineering journal, and that's available for anyone who's interested in reading that. And so then after we installed the full 100-foot barrier, we've had about a year to monitor that. We've been monitoring it seasonally, and so far the results are really promising. We've seen that in the inland groundwater, there's about 1 to 7 milligrams per liter of nitrogen, and then in the effluent, the treated water, there's 0.1 milligrams. So overall, on average, there's like a greater than 90% removal efficiency. So we're really excited about these results. And what's going on here is that we have the permeable reactive media, which is wood chips and a gravel mixture. And the wood chips are slowly being consumed over time by microbes, and the gravel actually increases the permeability of the media, so water is attracted to the barrier. So we're really maximizing the amount of groundwater flow and the groundwater treatment that's possible with this PRB.
And what makes our work unique in Cornell is that we have the ability with expertise of personnel and equipment that enables us to be able to map out and measure not only what's in that water discharging, but the rate of discharge. And that's important because all the shoreline is not the same. Some areas, like this one, have a lot of nutrients coming through, nitrogen, as well as high discharge rates. And we were able to quantify that, taking that information and using it for remedies.
There's a lot of water quality initiatives going on, as you know, and we see PRBs as a tool in the toolbox that are complementary to all of the other water quality improvements that are ongoing, like improved septic systems, improved fertilization practices, and living shorelines. All of these other types of things that are being used to improve water quality are really important, and PRBs are complementary to that. They can be used alongside those types of treatment to help provide immediate water quality relief and to help meet nitrogen load reduction targets.
We put in a small little permeable reactive barrier of wood chips basically behind a section of the bulkhead. And at the same time, that was about 2015, at the same time we were fortunate to hook up with Molly and Stony Brook to help do some research on that. And so it enabled us to have a pilot that we put in on our own expense in Stony Brook. You know, there was a Professor Nils Volkenborn we worked with very closely, and Molly was a PhD student under him. So that all came out of that, and that led to us taking that information and going to the Community Preservation Fund in Southampton and applying to put a 100-foot long PRB in based on what we already had piloted. And we were successful in getting that grant. And we've been monitoring it, and we've partnered again with the Clean Water Institute and Nils Volkenborn. Stony Brook is helping us to do some of the monitoring and continued monitoring and research.
Independent researchers have found that PRBs can last for decades, even more than 30 years, some studies suggest. And although PRBs do require a significant amount of money upfront because we need to characterize the site to make sure the site is appropriate, and we need to install the PRB. Those are significant costs up front, but because they last so long and they really require no maintenance after installation, they become very cost effective. PRBs are mentioned in the Suffolk County Subwatershed Plan as being cost effective, similar to other nitrogen reduction technologies. So we think that, yeah, for these reasons, they're a really promising technology to continue working on and studying, and to continue to improve the installation methods so that they are more cost effective and more efficient.
It's treating nitrogen that's atmospheric deposition, that's fertilizer, that's legacy, that's septic, and it's treating it right before it discharges. So you're getting an immediate relief in that area, kind of a triage, until all the other things, good things hopefully happening inland, are go into effect. So it's filling that gap before we can do better things with our land use inland. You know, we can get some relief. So that makes it a little unique. That's something we can do now, and that we've actually expanded it now to other areas of Long Island. We got a similar work now in Sagaponack, Georgica Pond, Accabonac Harbor, Shirley. So it's expanded rapidly with our ability to evaluate, assess, and remediate.
You know, Mark, I found this project really fascinating. Water quality is so important for Long Island, and as a SPAT member, I know oysters need clean water to grow with normal algae blooms to feed on. So toxic algae blooms caused by excess nitrogen can harm oysters and all bivalves.
Yeah, Roy. I work a lot of my time as a marine educator and, focusing on stormwater pollution. I've gone to many schools, talked to students about it and, civic clubs. And, last few years, Suffolk County and other municipalities have really worked to get the public aware of, the nitrogen problem in our groundwater and also in our surface waters that, causes excess nitrogen, causes algae blooms.
Yeah, and as Ron Paulson said in the story, we need many different aspects of stormwater remediation to improve our water quality on Long Island. So, Mr. C, I have a fun idea for our next show. Let's just show some of the different happenings that the CCE Marine Program staff saw on the water this past year.
Yeah, it's a great idea, Roy. Didn't they see some dolphins in Northport Harbor?
Yes, they did. And speaking of Northport, the town really stepped up for their anniversary. And I have a little clip of what they did. So, Mr. C, have a wonderful night. And what are you cooking for dinner?
Scallops, of course. All right, we'll see you tomorrow, Rory.
All right, see you all tomorrow.